Hello, welcome to my channel. My name is Cassiano. I'm a software engineer, and today I'm gonna show you a different way to generate the Fibonacci sequence using Python language. In fact, you can use any language that you'd like, but I will show you a different way from the traditional way of generating that sequence. Let's move to the code. Here we have a traditional code to generate the Fibonacci sequence. So in this code, we just sum the last value with the current value to get the next value of the sequence. So if we run this code here, uh, passing in 5, we have the first 5 Fibonacci sequence: 1, 1, 2, 3, and 5. But now I'll show you a different way to get the same sequence without using this sum. So we don't need to sum the last value with the current value. We use a different way. In this way, we're gonna use this golden ratio. This value, 1.618034, it's a golden ratio for Fibonacci sequence. So if we get the value and multiply by the golden ratio, we get the next value. So you don't need to make this sum. Let's try that. So I will duplicate this function and rename Fibo golden ratio. So we don't need these variables, we don't need this, we don't need this. We don't need this sum, we don't need this, and all we need is to update the current value, current times golden ratio. I will use the round function here because as the golden ratio is not an integer, the result will be not an integer. So let's check that. Fibo golden ratio 5. Unexpected identity, maybe something wrong. So here we have 1, 2, 3, 5, 8. In this way, the another one didn't print, so I just print the current value here before enter the loop. So let's save the file. So 1, 1, 2, 3, 5, 8, the same sequence. And if we put a different number here, we have the 21st Fibonacci sequence using this golden ratio. But how that works, why that works, that's the point, why that golden ratio works. Because if you get the any two values from the sequence, for example 13 and 21, if I divide 21 by 13, I will have a value very close to this ratio, very close. So let's check that. I will comment this code. 1.61, it's a very close to this. When you go further to the sequence, this ratio is getting closer, it's converging to this number. So this number is a very close approximation of a golden ratio. So that's why that thing works.